I'd like to start things off today by welcoming you and thanking you for taking the time to attend today's Technic Education Division over here at Studica. And of course, today we're going to take a look at some of the newest release from Fischer Technic's line of simulation models, that being the Agile Production Simulation model, also known as APS. Now, this new model is designed to demonstrate how the current challenges faced in production and logistics planning can be addressed, and it's designed to incorporate the best features of previous Fischer Technic models along with many new cutting-edge innovations. But before we get into the main focus of the presentation, I'm just going to provide you with a little bit of background, a little bit of an overview on Fischer Technic and its products. Now, the model we're examining today is one of the most recent additions to the Fischer Technic line of industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate both in appearance and in function various automated robotic machines that would commonly be used in commercial manufacturing environments. The Fischer Technic company has been creating tools for teaching students of all ages about how technology works for 60 years, all based around their unique building system. Now, what makes this system unique is that unlike other popular construction systems where the components are designed to simply stack, the Fischer Technic system was created with more of an engineering mindset. The core building block used in the system is designed to enable attachment from all six sides, and because of this, it allows for almost limitless design possibilities. Many of the parts that are used are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different and very specific parts available will also help technical builders to address equally specific design needs. The system was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in both the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, had held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. A couple of examples. Well, prior to creating Fischer Technic, Mr. Fischer was first noted as the inventor of synchronized flash photography. This was back in 1949. And a few years later, he gained fame as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, continues to employ thousands of workers all around the globe, producing many variations of fastening devices used in building construction. Up until very recently, they also produce numerous components used in automobile assembly. These days, they are also known for providing consulting services to companies who wish to employ state-of-the-art manufacturing processes, so you can see the new APS model as being in many ways in line with this strategy. Many people are most familiar with Fischer Technic's line of construction sets. We're just going to talk about them for a second. The focus of these building sets, whether those intended for the retail market or those that we represent, which are for classroom use, has always been about helping to foster an understanding of technology. The sets designed for use in the educational sector are most often focused on a specific subject area that falls under the umbrella of what is now considered STEM education. These sets address topic areas such as mechanics, pneumatics, robotics, renewable energies, many others. Now, typically students would use these sets in the classroom and they'd be asked to build a progression of models using the unique Fischer Technic building system, and then they would perform various experiments, create variants and enhancements to the model, and all of these things will help them learn and understand key aspects of the particular subject being focused upon. The line of Fischer Technic simulation models, which again are the focus of what we're doing, you're going to find in the system are going to be things like simple conveyor belts, multi-axis pick-and-place robotic arms, color sorting lines, high bay warehouse storage systems, and even complete material cycles. Now, besides these individual models, which will focus on specific automated processes, Fischer-Technic also offers numerous variations of an integrated factory simulation model. Now, these models will most often consist of four or more individual workstations, such as, for example, a vacuum gripper robot, a high bay warehouse storage system, a multi-processing station with an oven, and a sorting line with color detection. And these models are designed to all work together as one self-contained material cycle. Other variations of the factory will focus on the idea of Factory 4.0, utilizing IoT in the form of controlling and monitoring the actions of the factory from a web-based dashboard. Now, as we have a full-scale webinar presentation discussing each of these models in detail, I'm not going to touch on them too much here, but I would strongly encourage you to attend one of our upcoming presentations if you'd like to know more about these, or you can, of course, reach out to me directly for more information, and I'm going to provide my contact information at the end of this webinar if you'd like to do that. So, again, if you want to know about the other models, we can definitely fill you in. Now, before we get into our overview of the Agile Production Simulation model specifically, I'm going to first outline some of the advantages of using Fischer-Technic solutions. First off, Fischer-Technic simulation solutions allow educators to offer engaging hands-on tools for teaching, exploring, and most importantly, understanding various aspects of automation and programming. Now, this could be for understanding how automated systems work, or it can be for having a tangible and physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, again, in appearance and function, common automated systems, things like conveyor belts, sorting machines, robotic arms, and much more. Because of their compact size, they are not only ideal for use in classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. The next factor, and a very important one, is quality. Each Fischer-Technic simulation model is a high-quality German-made product. The majority of the models in the Fischer-Technic simulation line, including, of course, the Agile Production Simulation model, which we're going to look at today, the majority of these models are 24-volt models, which were designed specifically for use with latest industry standard PLCs. Now, while the APS model that we're going to be focusing on today already includes all of the PLCs and pretty much everything you're going to need to work with it, within the scope of delivery, many of the other Fischer-Technic models in the main line, where it again focuses on just a conveyor or what have you, will allow you to use the PLC of your choice. So it really doesn't matter what type of PLC you prefer. If you like Mitsubishi, Honeywell, Siemens, what have you, you should be able to use that PLC to control the basic Fischer-Technic models. And under the same by the same token, you can use your choice of programming language to control the models. Again, that really applies more to the other models than the ones we're going to be looking at specifically today. Now, next off, Fischer-Technic simulation models are cost effective. Now, if you have had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you're going to pretty quickly notice that the entry point for a lot of these products can really be quite high. When we're saying quite high, we can be talking about $80,000, $90,000 or more, and they can also be quite unwieldy, quite heavy, not easy to move around, things like that. Fischer-Technic simulation solutions, on the other hand, start at just a fraction of this price. In fact, we have several models in the basic line that start out under $1,000. And again, they're also compact, realistic, and high-quality learning and demonstration tools. Now, while admittedly the APS model we're looking at today is on the high end of the Fischer-Technic price range, it still offers significant value in terms of what it allows you to address at a still very reasonable price point. Again, still much less than that entry point I mentioned for those other models, and you would likely be hard-pressed to find a truly comparable solution available at any price anywhere. So with that being said, let's now move our discussion specifically to the Agile Production Simulation model and discussing what the term Agile Production means and why it's important. Now, here's a slide that I've used in several of the other fischertechnik webinars that we present, and it shows an early version of the Henry Ford production line model. Now, the Ford production line was in its own time a very innovative thing in that it streamlined production back in a time when the focus was on efficiently producing a large quantity of the exact same thing. Now, in this case, workers along the assembly line each focused only on a specific part of the automobile production process. For example, perhaps a worker was focused on installing a specific component, making a specific adjustment to something before the vehicle was moved further along the production line, where the next worker in line would again perform the specific task for which they were with, and so on and so forth, until the assembly of each model was completed. Now, when the goal was produce a large quantity of the exact same thing, this model worked really well. Of course, things are no longer quite so simple, and with good reason. Product customization must be considered, as well as the large number of assemblies and components that need to be used. Likewise, the increase in customization options which are available. Product life cycles are also much shorter now, with an increase in overlapping product launches and production mix. And flexible manufacturing requires an increase in logistics processes. So to summarize, industry must now deal with smaller batch sizes during the production process and increasingly complex processes. Now, this requires companies to better synchronize production and logistics, requires them to make investments in cutting-edge automation equipment and processes, and it absolutely requires them to be as efficient as possible. Now, as an example, consider the BMW model. This is pretty common in the production of a modern automobile right now. What you're going to see is the manufacturing processes here must be set up to efficiently and cost effectively address, in the case of the BMW, the 18 different engine options that are available to consumers, as well as the 5 different equipment packages which are available, along with 70 different individual equipment options. So with all of this going on, clearly the Henry Ford assembly line, which again was designed to quickly produce a high quantity of a single specific model, is simply not going to work anymore. So it's with this in mind that industry has increasingly transitioned from the assembly line production method, again, the Ford method, with its rigidity and constraints, and instead moving to methods such as the matrix production model, which eliminates the fixed time cycles and sequence of processes, or fluid production models, which also allow for an unlimited number of assembly scopes per station. So the most notable benefits of incorporating such agile production methods are in the area of flexibility, including the increased flexibility in production processes, being able to off customers specific mass production while avoid overcapacity, and also reducing lead time through a mix of different derivatives. Now, an additional benefit is being able to produce goods as specifically dictated by the wants and needs of your customers. And this is why fischertechnik created the new Agile Production Simulation, which again is the latest iteration of the fischertechnik factory model, this time not only incorporating IoT and state-of-the-art manufacturing processes, also AI. In addition, this innovative new model also includes a digital learning platform. First off, here's a quick look at the full factory. So companies with an eye to the future, again, rely on automation, modularity, artificial intelligence, and agility, all to help them remain competitive. Now, in order to help promote these topics in industry and in research, students, apprentices, and employees each require a clear awareness and understanding to enable them to deal with such complex issues. And this is where the fischertechnik Agile Production Simulation model comes in. It's designed to simulate processes such as quality assurance using artificial intelligence, the functioning of driverless transport systems, and to replicate automated processes on a small scale, from the receipt of goods into the system to modular production to quality assurance. The model includes several features not previously available in the fischertechnik simulation line, including an automated guided vehicle and a six-axis robot. The accompanying didactic materials help to translate the hands-on simulated processes into future skills for both students and teachers. Now, in addition, the digital twin of the model helps to significantly intensify the learning experience. Now, while we now do have a fully narrated video of the factory in action, first off, I want to provide you with a brief overview of each of the workstations or modules, beginning with the section where the incoming and outgoing goods are placed, which is referred to in the manual as the DPS, or Delivery and Pickup Station. Now, this is the module you see on your screen right now, and it's, of course, where the work cycle for the materials used by the factory begins and ends. The raw material, or in this case, one of the cylindrical work pieces, like you see right now underneath the vacuum gripper here, basically the workpiece enters the material cycle when it is delivered by hand to the goods receipt slot, where it is then picked up by the six-axis robotic arm that you see on your screen that uses a vacuum gripping device to pick up the piece. The workpiece is first positioned on the color sensor, after which it is encoded on the NFC reader. The six-axis robot located at the DPS station then places the workpiece onto this automated guided vehicle, or AGV as we'll refer to it, for transport to the next destination in the warehouse or in the factory. Now, I should mention that the DPS, the delivery and pickup station, also contains the central control unit for this, which is a Raspberry Pi, and it includes the environmental sensor, which is used to measure different environmental conditions in the factory. And at the end of a cycle, of course, after the workpiece has gone through whatever it needs to go through, the finished workpiece is delivered back to the DPS station, again by the AGV that you see here. So typically, if a workpiece was put onto the AGV, the next stop for a workpiece after the goods receipt station is usually going to be the high bay warehouse. Although, again, because this is an agile production simulation, the order of processes can be changed if there's a need for doing so, or a station can be eliminated if there's a need for doing so, what have you. Again, you can vary that up. But in any case, the high bay warehouse here contains 9 slots for workpieces. It has its own stacker crane and its own vacuum gripper that picks up the workpiece from the back of the AGV where it docks at the docking station, and it hands it over to the stacker crane for storage. This is where the workpiece is then placed in a workpiece carrier for storage, stored into one of the shelves at the warehouse, and retrieval as needed is done according to the first in, first out principle. The next module that a workpiece could go to is going to be the drilling station. The drilling station consists of a docking station for the AGV. Actually, each of these stations will have a docking station where the AGV, again, carrying the workpiece, docks over there. Typically, again, the vacuum gripper in each of these stations is going to have a vacuum gripper that picks up the workpiece from the back of the AGV, puts it onto a little conveyor belt here, where it is transported under a drilling head. Now, after the simulated drilling process has been performed on the workpiece is transported back onto the conveyor belt, back down there, picked up again by the gripper robot, and placed back into the AGV for transport to the next station. And let's say we're going to the milling station next. Now, so here's a slide of the milling station, and I will mention, since it's very obvious here, and since as I haven't touched on it earlier in the presentation, you will note that all of the models shown so far are pre-wired to a Siemens S7 1200 PLC, which has been pre-programmed. So again, each of these individual workstations you will see is already pre-wired to the Siemens PLC. We're going to, of course, touch on this again a little bit later in the presentation, but continuing along, much like we saw at the previous stops, the milling station, again, consists of a docking station for the AGV. And once again, once the AGV has docked the station, a vacuum gripper at this station, at the milling station, picks up the workpiece from the back of the AGV, and then it puts it onto a conveyor belt that's located at this station, where the conveyor belt transports the workpiece under the milling machine. And here, the milling of two pockets on the workpiece is simulated. After that process is finished, the workpiece goes back on the conveyor belt, down to the gripper robot. Gripper robot picks it up, puts the workpiece back onto the AGV vehicle. And then you could go to the quality control with AI module. Now, with the quality control module or station, once again, there's a vacuum gripper there that will pick up the workpiece from the back of the AGV, place it onto a conveyor belt. Here it gets transported under a camera where the workpiece is scanned. Now, I should also mention that the workpieces used with the APS factory come in three different colors. They come in red, white, or blue. And they can also have some possible machining features that are printed right on the workpieces, such as features that would simulate drilling, milling, or drilling and milling, as well as some possible fault patterns that can come up. Now, when this workpiece is placed on the conveyor and it's scanned by the camera scans each of these workpieces and it gets classified using trained artificial intelligence or AI. So depending on the color, feature, or fault pattern of the workpieces, the workpiece that gets scanned is either placed back onto the AGV as being deemed to be okay, or it gets sent to the reject container if they are instead analyzed as being not okay or defective. And just to provide a bit more background on the AGV, which transports the workpieces from one module to another, each AGV is controlled by a fischertechnik's Robotics TXT 4.0 controller. This is fischertechnik's proprietary controller, which has been pre-programmed using Python. The AGV itself is a track-bound vehicle that follows the printed black lines or tracks that you may have seen in some of the photos here that are on the factory floor. It uses ultrasonic sensors to detect obstacles that may be in its way. The vehicle itself has omni wheels, which allow it to move in all directions. Two buttons and a photo transistor help the vehicle dock to each factory station. And the AGV receives its driving commands from the central control unit that I mentioned before, and it uses a fischertechnik rechargeable battery pack as its power supply. Now, while each APS factory does ship with one of these AGVs, these automated guided vehicles, if you did wish to add an additional unit, an additional AGV to your factory floor, it can be purchased separately, and we'll touch on that after. And finally, I should mention the charging station. When the battery on the AGV, the automated guided vehicle, runs low, the AGV will navigate towards the charging dock, where it is automatically charged with a charger with charge monitoring. Contacts on the floor of the charging station connect the AGV with the charging electronics. So now that you have an overview of the makeup of the APS factory, the stations, what have you, I'm going to share a short video that will provide you with a look of the model at the model in action, along with more details that we haven't covered yet. And since we have a nice narration, I'm going to back up and let you listen to this. Hang on a second.
Welcome
here.
to
We
Fischer
may
Technic.
have. Let me turn this up.
Experience the Agile Production Simulation, an interactive.
Excuse my sound issues here. Okay, there we go.
Welcome to Fischer Technic. Experience the Agile Production Simulation, an interactive model that realistically depicts modern production processes. Agile Production Simulation, or APS, combines classic manufacturing processes with digital control and intelligent networking. From goods receipt to production to delivery, every step is automatically controlled, monitored, and documented. The system is based on real industrial components in miniature format: sensors, conveyor technology, robotics, all precise and functional. The dashboard can be used to monitor production at any time, execute order processes, and carry out simulation games. The simulation is perfect for education, study, and training, ideal for vocational schools, universities, and industrial companies. Complex topics such as lean production, agile manufacturing, batch size 1, condition monitoring, and predictive maintenance are clearly conveyed. The focus is not only on technical aspects, but also on economic and organizational aspects. The included digital learning platform integrates didactic accompanying materials with step-by-step instructions, as well as the digital twin. The individual modules are integrated into a higher-level control system via interfaces such as MQTT, OPC UA, or REST API. Connection to ERP or MES systems is possible, as is real-time visualization. This allows process data to be recorded, analyzed, and used for optimization, in line with Industry 4.0. The system has a modular design and can be flexibly expanded to meet the requirements of your training environment. Whether manual interventions, automated quality controls with artificial intelligence, or varying production processes, everything can be customized in just a few simple steps. This makes every training situation realistic and tangible. It is also important to provide learners with didactic guidance so that they can learn in a targeted manner in selected subject areas. Together with the Karlsruhe Institute of Technology, we have developed the aforementioned digital learning platform, which contains 4 specific learning modules on the topics of agile manufacturing, the Internet of Things, artificial intelligence, and automation. In the spirit of a consistent learning journey, each learning module begins with a theoretical section. This is followed by a practical section and a transfer task. The digital learning platform is based on a digital twin of the physical plant into which the learning modules are integrated. Also integrated are a production workflow, planner, and a dashboard of the most important production metrics, such as overall equipment efficiency and throughput time. These tools can be used to solve the tasks within the learning modules. The Agile Production Simulation from Fischertechnik, your practical learning system for the smart factory of tomorrow. Innovative, flexible, comprehensible.
Okay, so let's move right along and just quickly review some of the technical specifications for this. Again, it is a 24-volt power supply that's used with this. The central control is via Raspberry Pi 4B. The individual modules or workstations, again, as I mentioned, are controlled with the help of 5 different SPS Siemens S7 1200 PLCs. Again, if you noticed in the video, every workstation, aside from the charging station, which doesn't need it, but every other workstation has its own dedicated Siemens PLC. Additionally, the model includes 3 fischertechnik TXT 4.0 controllers, which are used to control the sensors and camera, as well as to facilitate the cloud access in the WA module for quality assurance with AI, and of course for the automated guided vehicle or AGV. There's a WLAN router for the WLAN network. Software used on the APS model includes SPS programs and structured text for the PLCs, TypeScript for central control and the Raspberry Pi, Node-RED for communication between SPS and the fischertechnik TXT 4.0 controller. You have Python for programs on the TXT 4.0 controllers, most specifically in the AI module, and TensorFlow for supervised learning and quality assurance with AI. Now, as was mentioned in the video, the APS model includes a cloud-based dashboard which can be used for order control and monitoring of the factory status, as well as for determining key figures. The factory has a modular design, with each workstation mounted onto its own base plate section. And a total weight of approximately 116 pounds. A storage case is available separately for protecting the model when not in use or when being transported, and of course, we're going to look at that shortly. And again, didactic materials are also included. Now, speaking of these didactic materials, I want to again go back to the digital learning platform that I touched upon earlier, or that was touched upon earlier in the video segment. The digital learning platform is a high-performance, immersive learning environment and is based on a digital twin of the Agile Production Simulation. Now, this serves as the educational counterpart to the physical factory model, and here the learning tool is used to clearly illustrate the control units, actuators, and sensors included on the model, and to demonstrate the full functionality of the APS. The platform offers interactive learning modules on agile manufacturing, IoT, AI, and automation. It enables the simulation and evaluation of highly complex process workflows in agile manufacturing. Now, as was mentioned before, the digital learning platform is a byproduct of the partnership between fischertechnik GmbH and the Karlsruhe Institute of Technology, the prestigious public research university located in Karlsruhe, Germany. Now, I also wish to emphasize that there are no additional costs, there are no additional fees associated with the digital learning platform. It is included within the scope of delivery when you purchase the APS. Now, this slide provides a nice breakdown, again, of what is covered by the digital learning platform. Now, as you can see here, users start with an introduction to the Agile Production Simulation, and this would begin with an interactive explanation of each of the process modules, as well as of the control units, the actuators, and the sensors. Following this, the main instruction is broken up into 4 separate modules, one focused on agile manufacturing, the second on the Internet of Things or IoT, the third on artificial intelligence, and the last on automation. Each unit or learning module will include the following: a theory section, establishing a fundamental understanding of the topic at hand. Next, a practice session, and this is where users can simulate and understand the processes being studied with both the physical mode and the digital twin version. Transferability, where students get to see how the knowledge they've acquired can be used in the real world. The digital twin forms the foundation for the digital learning platform. Once again, the educational or exploration mode of the APS is implemented using the digital twin. The digital twin can be utilized to solve tasks in the learning modules. The digital twin can be used to simulate complex challenges in an agile production environment. And among the tools included with the DLP includes this workflow planner tool and an analysis tool as well. So essentially think flexible, modular, agile, and connected. This is really what the fischertechnik Agile Production Simulation model is all about. Now, the APS model is the perfect tool to use in higher education. It's great for advanced CTE training, university labs, or for industrial training. It's an ideal tool for teaching about the future of production. It offers a hands-on learning experience. It provides a safe method for teaching these skills while also offering a tool that replicates, again, both in appearance and function, those types of things that would be used in industry. It provides a bird's eye view of a working factory, and it, of course, offers considerable added value with the digital learning platform. It's ideal for demonstration purposes for companies involved in areas such as IoT or software development, as well as for consulting. Now, in a break with previous fischertechnik factory releases, the APS model has been designed to allow for possible expansion, as we touched on before. Now, currently, there are two additional modules which are available for purchase separately, which can also be incorporated if one wishes to expand the functionality of the APS model. The first of these, as you see on the screen now, is the annealing furnace shown here. The addition of this production module unlocks further learning content in the digital learning platform. Both theory modules and additional tasks in the Agile Manufacturing Learning Model are made available. And these will cover topic areas such as introducing new derivatives into production and expanding existing production configurations with an additional process. The module, like most of the modules of the APS, again includes its own Siemens S7-1200 PLC, which has been pre-programmed in structured text. As an FYI, the annealing furnace module has dimensions of approximately 22.5 by 15 by 9 inches, and it has a weight on its own of approximately 10 pounds. But it is, of course, designed specifically for use only in combination with the APS model. This is not something you would use as a freestanding workstation like you would if you've seen our other fischertechnik models in other presentations. This is only for use with the APS. The second add-on module that's available for purchase, as we talked about earlier, is an additional AGV, which can also be incorporated into your. Now, like the annealing furnace and the add-on automated guided vehicle also will unlock additional content in the learning content in the digital learning platform. Both theory modules and additional tasks in the Agile Manufacturing Learning Prompt module are being made available with this. In this case, they're going to focus on Agile intralogistics, as well as the parallelization and prioritization of the production workflow. The model ships with a pre-programmed fischertechnik Robotics TXT 4.0 controller, and as with the version included with the APS, the programming here is all done in Python. Now, this can, of course, again, only be used in combination with the APS model, and it's not intended to be used as a freestanding model. The dimensions on it are approximately 10 by 7.5 by 5 inches, and it has a weight on its own of about 3.15 pounds. Now, as this concludes the main portion of our overview of the fischertechnik Agile Production Simulation model, we're now going to go over the costs of each of these items very quickly. First off, the main item, of course, the Agile Production Simulation, which that's its product number 569289. Again, it includes 5 Siemens S7-1200 PLCs and 3 fischertechnik TXT 4.0 controllers within the scope of delivery, as well as access to the digital learning platform with the digital twin. The cost for the APS is $35,175. The APS add-on module, the annealing furnace 571909, which again includes a Siemens S7-1200 PLC, and it again unlocks additional didactic content in the digital learning platform. The cost for this module is $4,439. The additional APS automated guided vehicle, the AGV here, 571908. Again, with the purchase, this will unlock additional didactic content in the digital learning platform. The cost for this one is $2,589. Now, there is also one more item to cover very quickly, and that is, of course, the storage and transport case, which was designed especially for the Agile Production Simulation model. Now, as the APS model is obviously a very substantial investment, this is a great option to help protect the model when not in use, or of course, if you do need to transport it safely. The case itself has an aluminum case maker profile with plastic plates. Each of the 2 separate case sections has steel tilt handles and angle protection corners for additional stability. There are also straps and internal zipper pockets that are used for storing cables, cords, workpieces, other accessories, various things that you're going to deal with. The lower section of each of these case sections is lined with hard foam, while the upper sections have some foam in different case, the total weight of model and the case are approximately 190 pounds. I do want to note that even when the model is kept in the storage case, if you are transporting this model, it must always be shipped flat as freight on a pallet. The cost for the storage case is $4,799 each. So, if you do have any questions, this is where I would ask you to either type them in the question and answer window or the webinar chat window, both of which you can find located on the Zoom toolbar. If I don't see anything coming up, I will tell you how to take the next steps. So, if you would like to request the full color fischertechnik Higher Education Industry Guide, which will describe the APS model, provide more details, there's also an APS fact sheet we can send you. If you'd like to request a quote for this, or if you'd like to speak with your dedicated educational representative about this or other fischertechnik options, you can call us here directly. Our number toll free is 888-561-7521. You could email us. If you're not sure who you need to speak to because you may not know your rep yet, you can just email us at info at studica.com, and just let us know if whether it be the APS or anything else that you might be interested in learning about. Just let us know and we'll get you in contact with someone. If there is anything that you would like to talk to me about directly, again, being that I'm the product manager, if it's anything fischertechnik related, whether it's the APS that we looked at today, or if it's other fischertechnik simulation models or fischertechnik classroom products, I'm happy to answer your questions as well. Again, my email is up there, lance.zurek, lance.zurek, again, at studica.com. So, on that note, I thank you again for taking the time to attend. We hope you have a great afternoon, and I look forward to hearing from you soon. Take care.